Hello, I hope you're well. Welcome to this tutorial on how to blink an LED with your Arduino. I know, blink an LED? Sounds kind of lame. Okay, I will agree, blinking an LED is not quite as cool as, say, building a flux capacitor. However, in this tutorial, you will learn some of the fundamental functions that allow you to create awesome things. Because this course is not about building my project ideas, it's about enabling you to build your awesome projects. So what will you learn in this lesson? First, you're going to learn how to set the mode of a pin on your Arduino, either as an input or as an output. And this is a function that you're going to use everywhere. Second, you're going to learn how to write voltage to digital pins on your Arduino. So you can either write voltage high, say to turn on an LED, or you could write voltage low to turn it back off. It's just an example. So again, this is a function that is really important to understand. And finally, you're going to learn how to put in delays so that voltages can be applied for specified times. Okay, enough chatting. Let's do this. For this tutorial, you're going to need an Arduino board. I'm using the Arduino Uno. You can use any Arduino board, a clone or whatever, but I would recommend for this tutorial series, it's probably best if you stick with the original Arduino. That way we know we're on the same page. You're also going to need an alligator clip like this, and you'll need a 220 ohm resistor that's got a red, and a brown line on it, and you will need a light emitting diode, LED. I have a red one. It doesn't matter what color you have. Now the light emitting diode, it's got two legs on it. One is longer than the other, and that's not by mistake. The long one is called the anode, and the short one is called the cathode. And the anode is where you want to put the positive voltage, and the cathode is where you want the negative voltage to go. So I try to remember that, like, cathode is spelled C-A-T-H-O-D-E, so the first three letters spell the animal cat. So I think of cats as generally negative creatures, and so I think, okay, the cathode needs to go, the negative needs to go on the negative side. And then, like, since it's shorter, I think, okay, maybe there was this cat and it got in a fight and its tail got bit off, and so, you know, its tail is shorter. Okay, and then if you notice, if you look really close at a LED, there's this little ring that goes around the bottom that's wider than the rest of it. And on the cathode side, there's going to be like a little notch, or it might be flat. This one actually has a little notch. Most of them, I notice, are generally kind of flat, and that's just another indication to let you know which side is which. Okay, now technically speaking, you actually don't need the light emitting diode or the 220 ohm resistor or the alligator clip for that matter if the Arduino board that you're using has a built-in LED, and most of them nowadays do. See, it's right here. It's a built-in LED, and it's in line with pin 13. So I prefer using the external stuff just because I think it looks cooler. But if you don't have this other stuff, just go ahead and use the LED right there on the board, and you can jump in and get started. Well, let's go ahead and set up the circuit. It's pretty easy. So what I'm going to do is I'm going to take my resistor, and it doesn't matter which end I stick in here, but I'm going to stick it into pin 13 like that, and then I'm going to kind of bend it away. Then I'm going to take my light emitting diode, my LED, and I'm going to put the cathode, remember the short leg, and I'm going to put that into ground. Now ground on the Arduino is at the lowest voltage on the board, alright, so it's going to be 0 volts. And then I'm going to kind of pop that leg out like this. This is purely for demonstration. Then I'm going to kind of get this guy over here, position it, and I want to use my alligator clip and connect them like so. Wow, that was hard. No, you see, that was pretty easy. So that's all I had to do. Not too bad. If you didn't have an alligator clip, maybe you could use like a solderless breadboard and plug them each into that like so, but that's pretty much it. The resistor goes in pin 13, the light emitting diode, the short leg, the cathode, goes into ground, and then you connect the other two legs. So that's it. Then all you have to do is plug plug this into your computer with your USB cable. Alright, so go ahead and make sure your Arduino IDE is open, and then go to File, Examples, Basics, Blink. So here is the Blink program. Again, it comes pre-installed with the Arduino IDE. And what we're going to do real quick is just talk about the 4 big blocks of code that you will find in most Arduino programs. So the first block of codes is the comments. Okay, we've touched on the comments already. They kind of describe what's going on in the program, and it talks about some other stuff. Then we have a block of code that has the variable declaration and initialization. And then we've got the setup block of code. And then finally we have the loop block of code. So those are the 4 big blocks that you can expect to find in lots of Arduino functions. It's not always that way, but this is a pretty typical setup. So let's go ahead, let's look at that first block of code, which is the comments. So again, this just gives a one-liner for this program. It says what it does, turns an LED on and off for 1 second, and it does that repeatedly. And then it gives information. It says that this code is in public domain, which means to you and me that we can do whatever we want with this. There's no restrictions to our use of this program. Now, some programs you run into, they're going to have a lot more to say in those comments. They might have a book written, for all you know. But in this case, it's just short and concise. So it's always a good habit to read the comments at the beginning so you know what you're getting into. Okay, so let's move on from the comments to the next block of code is where we initialize and declare variables. Now, you should have listened to the variable tutorial prior to this example, so you should be kind of familiar with what a variable is. But I might throw out some words that you might not sure what it means, but that's all right. It's really going to sink in with time. So let's look here what we have. We've got one variable being declared and initialized. So the variable being declared is named LED. So LED, LED, and it is an integer. That's what the int stands for, and you'll notice that int is brown, and we've set this integer variable equal to the number 13, and then we finish off that statement with a semicolon. So we have we've declared the variable, which is saying int LED, and then we initialize it. We assign a value to it equal to 13. So the declaration is when we're naming it and giving it a data type, and the initialization is when we're assigning a value to it. So here we've done that all in one line of code. We declare and initialize. Okay, so what does that mean exactly? So basically what we're doing is we're creating a variable that this program can look to and say, what Arduino pin am I going to be looking at? And you can look right at the comments above that. It says pin 13 has an LED connected on most Arduino boards. Give it a name. So in our circuit setup, we went ahead and put an LED into 13. So now I want you to know that LED, that variable name could have been anything. We could have named it caution LED, or we could have named it Maxa, or Niagara Falls. It really doesn't matter what we name it. But we want to use a descriptive variable name, so that's why we went with LED, because that's pretty straightforward. And where is it attached? It's attached to the digital pin 13. Alright, so that's enough about this initialization and declaration of variables. Let's move on to the next block of code, and that's void setup. So what do we need to set up in this function? Well, in this function, we have to set the mode of the pin that we'll be using on our Arduino. So we know we're using pin 13. And we actually want pin 13 to act as an output. We want to apply voltage to that pin. Well, there's actually 2 options we have with the digital pins. We can either set the mode to be an output, or we can set the mode to be an input. So if it's an output, like in this example, later on we can apply a high voltage to that pin, or we could apply a low voltage. If we had it set as an input, then we could read voltage. So basically, if we set pin 13 to an input, it would sit there listening for voltage changes, either high or low. But like we've already said, we want to light up an LED, so we want to apply voltage to this pin. So how do we go about setting the mode of the pin? Well, we use a function, and it's called pin mode. Very nice descriptive name. And pin mode takes 2 arguments. The first one it wants to know is, well, what pin are we talking about? And then the second argument it wants to know is this going to be an input or an output? Here's our example. We've got pin mode, LED. So what is LED? Well, LED is what we said it was back at the beginning. We said it's equal to 13, so we're just referencing that variable. So when you look at LED there, just think in your mind, well, LED actually means 13 in this case. And then you see the comma, the next argument, we want this pin to be an output. So that's all it really took. Again, pin mode sets the mode of a pin, either as an input or an output, takes two arguments. It wants to know the pin number and it wants to know the mode. And that's it. So we finish up setup there, and that's all it really takes here. So let's move on to the next block of code. So now we're into void loop, or the loop function, and loop is what will run over and over again until you either remove power from your Arduino, or if like a sledgehammer comes down and smacks it into a million pieces and it can't work anymore. Alright, so the first function we encounter is called digital write. Digital write takes two arguments. It wants to know the pin it needs to write to, and then it wants to know, well, what type of voltage do you want to put there? Do you want to put high voltage or low voltage? So high voltage is like 5 volts, low voltage is like ground. Okay, so do you want to apply a lot of voltage or do you want to apply no voltage? Okay, so, well, what do we want to do? We want to write what pin? Well, we're interested in pin 13 because that's where we have our LED attached. So let's go ahead and write high voltage to the LED. So when we write high voltage, that 5 volts is going to be applied at pin 13. It's going to go through the resistor, or the current's going to go through the resistor, through our LED, and then we're going to get light coming off of the LED. That's pretty cool. And you know what? It's going to stay that way. It's just going to come up, it listens to that command, and that's what it does. Well, how long do we want it to do that? Well, this is how we do that. We use a function called delay. And delay just delays the amount of time, and it delays it. You have to specify the time it delays in milliseconds. So here we're looking at 1,000 milliseconds, which is 1 second. So let's recap here. We use the function digital write, which is basically applying voltage to a digital pin. So digital write. What do we want to write? Well, we want to write to pin 13, and we want the voltage to be high. Well, now what do we want to do next? Well, we just want to delay for 1 second. Well, why would we want to do that? Well, we want to see the LED on for 1 second. Okay, well, alright, so now it's been 1 second. Now what do we want to do? Well, now we use digital write again. We write to pin 13, which is that LED pin. And now we specify low voltage. So what happens when we turn it to low voltage? Well, it goes from 5 volts down to 0 volts. And now our LED is going to turn off. And what do we do then? Well, we delay for another 1,000 milliseconds, which is 1 second. And essentially what we've done is we've turned an LED on, and then we've turned an LED off. And that, in essence, is blink. Alright, so what happens when we get to that last curly bracket in the loop? Well, we just start right back at the top again. So now the program, it just turned it on, it turned it off. Now it's going to go right back to the top. It's going to look, hey, digital write, LED, high. So it's going to turn the LED back on. It's going to wait a second. Digital write, LED low. It's going to turn it low. It's going to wait a second. And then it just does that over and over and over. Can you imagine how bored your Arduino must get? I mean, it just turns the LED on and off. I mean, for a long time. So, I mean, that's it. That's Blink in a nutshell. So let's go ahead and take a look at the board and see what's going on. Well, there you have it. The LED is blinking. You see the onboard LED is also blinking. Stays on for a second and turns off for a second. And that's pretty much Blink in a nutshell.